One.
Welcome, everyone. So, in this episode, I have Sky. Yes, Sky.
We are back.
We're back. Okay. But the rest of the team is still
Yes.
not available at the point in time.
Just
But
the two of us.
yes, awesome. So, today we are going to talk about APIs. No, it is not what you get when you flick the lighter. It's not api, not fire.
I know you're going to do that, you know. Seriously.
Not that.
I just knew it.
Not that. Okay. It's
Itu bukan api ya.
programming. Bukan itu api ya. Not that fire. This one is application programming interface.
Ladies and gentlemen, welcome to Security Lah Podcast Season 2.
So essentially, what it is, I'll give you an example so you understand better. All right. Just say I've created a mobile application called My Contact. And the mobile application function is to store all my contacts in a cloud server so that if I migrate my phone elsewhere, doesn't matter. I still have access. I just download the app and I can do that. All right. So what happens is when I build my mobile app, whatever you see on the screen, the UI and the UX, the user interface and the user experience, is just the look and feel of that app. It doesn't do anything else. How the app stores the information in the server, how the information in the server is retrieved and given back to me, how the server ensures that the data that I keep doesn't interfere with the data that Sky keeps. All that is handled by the server. And the way that the mobile app talks to the server is using this API connectivity. So this, in a very, very simple nutshell, is what the API is versus what the mobile app is. So today
and because of that, I am now API certified.
Yes, you are now API certified, right? So now the whole idea is we want to talk about the API bit. We're not going to talk about the mobile app bit, but why is this topic important is because almost all the organizations I know have started exposing an API either out to the public or internally, and APIs don't get the same kind of security love that web applications get. In fact, today, any web applications going live, the first thing to do, hey, let's do pen test, let's do black box test, let's do white box test, blah, 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 all that kind of stuff. But the APIs, well, for some reason, no one seems to be looking at the security of it. And the API today has access to more data, and most likely it's open. There's a lot of issues surrounding APIs. And I think today's Sky, let's cover a few of these topics,
Sure.
which may have a problem. So what's the first on the list?
Before you actually start on the list that we want to go through, do you have an example of an API attack that we have seen in Malaysia?
Very good one. An app that you hate to use, but you have to use.
What is that?
MySejahtera.
I thought you're going to bring some acronym or something.
Okay. Well, we are talking about what's happened in the past, right?
Okay.
And this is well documented. Everyone knew about it. You could abuse the MySejahtera API to send an SMS to someone.
Hey, that's nice. I've seen that. I've received one of those.
Yes, I got that too. So eventually they found out that the API didn't have the right level of authentication, authorization, data validation. Long story short, lack of security.
Yeah.
So that was an example that I can't say any other app because chances are a lot of apps that I use, very few people tend to use because you and I, Sky, we are security folks. So we tend to use apps that are a bit more secure or changgih compared to the rest of them. So My Sejahtera was one that I could call off my head and then say everyone would know this and relate this. And for those of you who's listening out of Malaysia, My Sejahtera is the contact tracing app that the Malaysian government deployed to everyone. And even if you're a traveler down to Malaysia, you are required to have My Sejahtera installed, your data and everything there. I believe very recently the government has said you don't need to use, for travelers specifically, you don't need to use that app to register. So that's a good thing. All right.
But it has a new look now,
Honestly, I have not
You
opened the
never
app.
upgrade. Ouch.
I haven't
Okay,
found the
never
need.
mind. We'll
I
cut
haven't
this.
found I haven't found the, I'll be honest with you, I haven't found the need to, because I'm pretty much at home most of the time. I work from home.
Okay.
Benefits of my job. And
Okay.
okay, so I think let's move on to the
No
topic.
problem.
We digressed
Okay.
a bit too much.
All right, all right. So the first thing that we probably want to look at will be broken object level authorization.
Okay, so how does this work? I will use the My Contacts fictitious app as an example. Right now, in the cloud server, just say for this app, there's only two users, myself and Sky. Right, so we are the two beta users of this app. Now, I will store my contacts through this app using the API, and so will Sky. Right now, each app is assigned an object ID so that the application can refer to it, you can index it. It's how the application manages the data, and that's how the application works. So with broken object level authorization, what it means is that I now snoop around and I find, hey, there's an API call running between my phone and a server. So let me look at this. Contact ID equals to 1 is my friend Joe. Contact ID equals to 3 is my mother. Who's contact ID number 2? Let me try. Okay, server.com:443/ contact ID equals to 2. Oh, it is Sky's wife's contact. I don't have Sky's wife's contact. Oh, Sky is a customer. Oh, it's his contact. Oh, so essentially broken object level authentication basically means is that using that API call, I'm able to access data that doesn't belong to me. So for example, it's like me accessing data that belongs, say for example, if I'm using a banking app, I can see Sky's transaction instead of just seeing my own data. So that to give you a nutshell as to how that is.
So is that a problem with the application, or is it a problem with the API?
It's a problem at the API level, because end of the day, before you give out any data, there should be some level of authorization check to see if you can actually give out that data.
That's right.
Right? So for example, your contacts should be only for you.
Exactly.
I shouldn't be able to see your contacts, right? So that's an issue.
Okay, let's go to number 2 then. What about broken user authentication?
I think this is kind of simple. We authenticate users. So authentication essentially is a process to identify you are who you say you are. And the way any application does it is that they present a username and you put in a password, and now you put a two-factor authentication, right? So the problem is sometimes is that, I'm also a developer. I also write code. Sometimes I tend to write codes which are also insecure. And for example, what happens is, just say if you're authenticated. So if you put in username, password, you are authenticated, right? What happens is you don't have to send in your username, password again. So you send it once, and then after that session is established and fine. See, some developers, they take an easy way out. They say, okay lah, I just had a header authenticated equals to yes, and then I put all my parameters behind. So instead of checking whether there's a session established, anyone who just put the keyword, I'm giving an example, authenticate equals to yes, and then ID equals to 5. So I just have to have that word authenticate equals to yes for me to just use the API, all the functionalities in the API. So I don't even have to authenticate first. So essentially what we are saying for this problem is that the authentication mechanism is flawed. The other issue, like what we've probably had an offline conversation, is that you happen to get somebody's laptop just to do some work, and suddenly you realize that when you go to facebook.com, they have already been logged in.
Yeah.
Right? So if they haven't logged out, then there should be some sort of a timer that says, okay, I give this session 5 minutes inactivity. After 5 minutes, connection should be disconnected and do something about it. Of course, there's always a drawback between how we allow things and user experience, right? So security versus user experience is always a catch-22 situation where we want to give the user a bit more flexibility, but there's always this issue of how do we make sure that the session is secure. So essentially, that's in a nutshell about broken authentication.
Number 3 on the line is excessive data exposure.
So this is one of those problems where there are some data that user creates and there are some data that the system creates. So back to my fictitious app, My Contact. Now, if you notice in the earlier example, I said contact ID equals to 3, contact ID equals to 4. Now, this information is something that should not be public or discoverable. All right. If you make it discoverable, then you realize, oh, maybe there are other parameters. What if I can just try different parameters to see what happens? Because usually what happens is the way API works is the query happens in a URL, in a URL, and the response, usually what they do is they give it to you in a JSON format. So a JSON format is just like a tiny little document with all the fields, everything lined up. And sometimes the information that's returned to you may be more than what you're seeing. So for example, when the JSON gets returned back to your mobile device, and if you look at the JSON packet, you see, oh, okay, so I have a contact name Ali, and this contact is also existing in Sky's account. Oh, so this is looking at the raw data, but then the screen limits what you see. So that's where the thing is. People think that if I can limit what you see, I can hide everything else. But the data has been returned into the whole thing. So I now know that Ali is also in Sky's phone.
Enjoying the show so far? Subscribe now so that you don't miss out on the latest episode. We are available on Spotify, Apple Podcasts, Google Podcasts, and many other platforms. Visit podcast.securityla.asia to get the links to subscribe.
That's what you call that excessive data exposure. You don't return the set of data that only you need. You return everything else that's also in the database. Because sometimes the way we arrange things in database may be different from how the user sees it. So for example, how that example can exist is like, say I'm the application developer, and I know that there will be a lot of numbers that are cross-referencing. So for me, I'm thinking, if I allow everyone to just write context into the server, you know what's going to happen? My server may have the same number 10 times, 20 times, 100 times. I'm going to waste space, isn't it? So what if I store only one instance of the number, and then I just link it to everyone who has access to the number? Wow, hooking.
Is that what's happening? I mean, on some of these breaches?
Because it's the way how the data is connected. So the issue is not so much of how the data is connected in the back end. It's how much of data that the API returns to you. Now, by right, the API should only return me the name and the contact number. It shouldn't tell me who else is linked to. That's what it means by excessive data exposure. You get back a lot more information than what you're actually asking for. I just need one name and one number. That's all. But you give me a whole lot of stuff, which honestly I don't need, right? So that's what's happening, because there's just too much of data. It's just that developers assume you're not going to put a burp proxy in between your mobile app and the server, and you're not going to be looking at all the traffic coming in and out. But the reality of the situation is anyone who has access to your app can put it through a proxy, can see what kind of connections you're making, and can do a whole lot of things. So you have to design with the thought that someone is going to break into your app. So if you design it with that, then then you can do stuff lah. Otherwise people are going to get smart and they're going to be able to read all these things.
While it gets technical, it's getting interesting. Let's go to number 4. It says here lack of resources and rate limiting.
Okay, so APIs, every time you launch an app, there will be an API call. All right. And I can give you an example.
Nice.
I was working in FSI at that time, and we suddenly realized that online banking started spiking up. So we were wondering why it's spiking up. It's not even end of the month. There was no batch runs, nothing. So we started digging in and we found out that there was an excessive API call. Somebody was triggering API call. So we were wondering what's going on. So we narrowed it down to one account. This guy was querying balance almost every second. Every second there's a request, So it seems like it was automated. So every second, give me balance, give me balance, give me balance, give me balance. So we're wondering what this guy is doing. So we did an investigation, eventually became a police case, and we found out that the guy was running illegal gambling. And what he was doing was he was checking his account constantly so that he can serve his customers. And because at that point of time, that resource didn't have the rate limiting, we weren't able to throttle his connection down. So the ability to throttle connections to prevent abuse, because most likely if it's automated, it's most likely either an abuse or an attack, right? So what happens is you can say that we can launch a DOS, denial of service attack, by constantly querying the app. Right?
I remember there was a case where one of the banks was mentioning that one of the guys out there was mentioning that this particular bank is very strong in their architecture defense, but their app was pretty weak because somebody just has to do a script to crawl the application on the web and begin querying and pulling down every tab on a second by second basis, and then the app will die.
Yeah, because you don't have infinite resources, you have finite number of resources. So if you have servers that can do 100 transactions per second, that's the limit. You go beyond that, then the server can't respond to you. So the assumption is always that users will be good, they will do what they need to do, and that's it. So for the fictitious My Contact app, the assumption is that I will just query one or two numbers and that's it. I won't be doing parameter walking or IDOR, where I just put contact ID 1, contact ID 2, contact ID 3, and I run a script that enumerates all the contacts that's available on the server on a second by second basis, which means that suddenly the load of that transaction, because there's so many transactions coming in, and API connections are asynchronous. What it means by asynchronous is that while I'm processing one request, another request can come in. And while this request can come in, another 200 requests can come in at the same time. Because that's why we use terminologies like TPS, transactions per second. How many concurrent transactions can you actually do per given time slot, which is, for example, 1 second? And without the ability to rate limit or to throttle down per user or per connection or per API, what happens is you are opening your backend into these kind of attacks. And that's how your servers can be overwhelmed.
But who has this data to be able to prepare the application? I'm sorry, because it's getting interesting and I just want to know for myself. The rate limiting.
So for rate limiting, there's a few ways you can do it. Number one is you can use a web application firewall. Most web application firewalls that I have seen allows you to rate limit connections. And some of them are even API aware. So you can even say that, okay, for this function, I want it maximum per IP or per connection or per session or whatever. And some of them are actually session aware. So they know that, okay, there's a valid session, so they can rate limit per connection. It's similar to how we protect web servers. It's the same exact technology that we would use. And using that, you can actually then say that, okay, so these authentication functionalities, I want it to be maximum 100 TPS. Bank balance transaction 50 TPS per customer per session. So you can go down into a very granular level for you to see how it is. But before you even do that, the first thing you need to know is what is the usage level of your APIs. So that's the first thing you must have. You must have a baseline. Then you can set all these parameters.
Okay.
Imagine if you don't know what the baseline is, you just go in and you set some parameters. Two things can happen. Number one, either you get overwhelmed by requests that your server doesn't respond because it's blocking the connections. Number two, your margins are too high. When an attack comes, it just goes through. So for you to actually be able to do this, the first thing you must do is you must first benchmark what is your usage like. Say, for example, on a normal weekday, what is your usage? Month end, what's your usage? Say if you have promotions and peak period, what's your utilization? And some of it may not be static. You cannot just say one limit and then you say, okay, fine. You're suddenly having a promo, your number of requests goes up, it's going to hit and it's going to fail. And I've seen organizations do these things and fail, not because they don't have protection in place, it's because they have the protection in place, but they didn't fine tune it based on the situation that they're supposed to encounter. Because some of these are manual. You have to go in and specify. It's not like an AI based rate limiting where it automatically learns and all that. Right?
Okay.
So what's the last one, Sky?
Okay, last one is broken function level authorization.
Okay, so this one goes into, you know how when you have system, let's not talk about API, let's talk about a web server, right? You have a web application, you have your normal user access, your user logs in, goes in, have their functionality and all that. And of course, you have the admin page, which is only for admin, right? The functionality is for admin. And the same thing also is there for APIs. So here, what we are saying is that the admin level functions are being accessed even though they only have user level permissions. So for example, today, a lot of times people will say, I don't tell you what the API URL, you won't know lah, and it doesn't take long to discover these kind of API endpoints. There's so many tools out there that already has a set of commonly used API endpoints. So for example, it can be webservices.com/admin.php or whatever example. So that may be the endpoint for administrative access. So once I know that's the endpoint for administrative access, I can try. Let me try unauthenticated. Sure, it's going to complain, you need admin access. Okay, fine. What if I put admin equals to yes, and then I put the URL? Oh, jalan. That means you just need admin equals to yes. That's all. So remember, it goes back to the earlier one, broken user authentication.
Yep.
So you can combine a few of this and actually launch an attack against your APIs. So it's not just like, oh, I just have this vulnerability. No, you can work together and you can work in tandem. So if you have some of these things, for example, if you do your rate limiting, you can prevent the number of attacks that comes in for someone to do password spraying. Just spray the password to see if it goes in. So if you rate limit, you can actually delay that process, or you can even say, fine, if this account has been sprayed too often or whatever, you may even choose to disable and get the user to log in and do a two-factor authentication, whatever, to re-enable it. Right? So this is essentially what broken function level authorization is, because you don't want the users to get access into the admin functionalities. You just want them to stick at the user layer so that whatever functionality that's given to them is only them. And even then, within users, you may have different levels of users. Some users may have more permissions compared to other users. So when they have more permissions, they have access to different kind of API endpoints. So even within a user, you may have different level of users, different category of users. Say, for example, I'm a user. I only have the ability to submit my claims, for example. And then my manager, who has manager access, can go in and approve my claims. Imagine if the functionality is not broken up, not compartmentalized properly. I can go in, if I find out what the API endpoint is, I can go in and say, this is my claim ID is 1234, approval equals to yes. And in the system, the claims is approved. It's going to go to finance. Finance is going to say, oh, your claim approved. Okay, bank, So that can happen, right? So even within user level, you need to make sure that the functions are separate. The API should say, oh, you are authenticated, but you don't have access to these functions. I should deny you. So it should be an error 404 or error 400, whatever, to say, I'm sorry, you don't have access to this API. All right. So these are the top 5, and then they may not necessarily be useless of their own. A combination of this, like what I explained earlier, can bring your API into a whole lot of trouble. And it's a good thing that you should start looking at this now rather than waiting for it to be abused. Because once it's abused, someone could probably pull your whole database out. And if it's a very patient hacker or a cracker or a threat actor, now what can happen is the person knows, if I spam every second, these people are going to find out that I'm doing this. What do I do? Very easy. I put timer. I only query one record every 1 minute. Okay, I got the whole time in the world. So I query one record. I stay quiet for 1 minute. I query another record. I stay quiet for 1 minute. And then eventually, at some point of time, you would have gotten all the records up to the point where the server says, okay, I don't have any more data. So it really depends on how the attacker thinks. The attacker is also security mindset. He knows these things, you may have to put all these things in place. Then you have to start looking at different kind of logic to put in the application to find out if somebody is actually exfiltrating data out using your APIs. Because some of the data breaches happen not because the application is insecure, your UI UX is just your UI UX. But if your API endpoint is open, someone can abuse it, someone can pull that data out. Chances are they will, and they can, and they will do that. They will definitely pull that out.
Great. I was just scrolling some of the things that I'm seeing in the market this couple of months, and somebody mentioned in a report that 1 in every 13 cybersecurity attacks are blamed on API insecurity. Would that be the right percentage we're talking about?
Yeah, definitely. In fact, if you ask me, I think there'll be definitely more. And the reason being is because, like what we've discussed before, organizations don't report. So, and also they may say, yeah, we may have lost the data, but no one is going to come up, put their hands up and say, yeah, we lost our data. It's because our API was insecure. Someone just basically cycled the whole API and pulled everything out. Nobody's going to say that, right? So as a result, the number may be low, but to me, if you ask me, it's most likely higher than what's reported, because there's a lot of issues or incidents that may not have been reported at all.
Okay, that sounds really, really scary, isn't it? Because I remember working with a attack surface management solution, and I could all they wanted from me was a name with the URL. In other words, a company name and what's their URL. That's all they need to know. And within 24 hours, they could actually map the entire organization. What are the applications on the internet that is available? What are the servers that's hosting all this? The server's host name and the operating system and the versions and the firewalls that's protecting the entry points and what firewall it is, to what patch level they are being done. And they could actually find out all information about the directors and the owners of their emails and also personal emails, and if their personal emails have actually been breached in the dark web. Just with one name. I was like, oh my goodness, how do you guys do this? We're not doing anything illegal. This is all available on the internet.
Yeah, most likely they'll be doing open source intelligence or OSINT kind of
Yes.
searches.
I was like, oh my goodness, how can you do this? I thought they went around. I said, no, you can check with your customer. Nobody told us anything. And they even went to the extent and say there is 2 servers in beta testing, but it was placed on the internet just 2 days ago.
Wow. Interesting.
Yeah.
Wow. There's
So
a lot of this.
Can you
services,
imagine? Can you imagine if these guys are the hackers?
But I'm sure the hackers would have same kind of information
Of course,
if they wanted to. If they
Yes.
wanted to, you know. So we hope that this episode has given you some clarity and visibility into why API is important, because we are seeing a lot of attacks that's targeting APIs, because they're all exposed out to the internet. There's sometimes it's just open to everyone. You just have to map the endpoints and voila, you
So-
get access to a lot of data.
So for those of you who are out there and you are familiar with API security, you probably know that we are referring to OWASP top 10, and we have only mentioned 5. I don't know if we have time after this, we may bring up, or will we be doing the second part?
Yeah, let's see how it goes. So
Yeah.
if there's a lot of feedback and you guys want to know more about the second half of the API security, drop us a note at our socials. We are in LinkedIn. Drop us a note to say that you'd like to know more about this. And Sky and I, and probably Nigel, Prof, and Kat, we may come in and do the part 2 of API security. So drop us a note so we know you're listening to this, and if there's enough attention and request, then we'll definitely do that.
Thanks, Doc. I've taken a lot of notes tonight.
All right, awesome, great talking to you, and please, I hope to see you guys soon. Take
All
care.
right. Take
All
care.
right, bye-bye.
Bye-bye.
Thanks for joining us this week on Security Lab. Make sure to visit our website at securitylab.asia, where you can subscribe to the show in iTunes, Spotify, or via RSS so you'll never miss a show.